Coming up next on CNFY.
Welcome back live to CNFY, Chemistry News for You. I'm Claire Combs.
And I'm Olivia McCoy.
And we are back from commercial break with breaking news about glycations, carnosine, and hemoglobin. The Marshall University Biochem lab students have found shocking and world-changing information. Liv, don't you agree?
I do agree indeed. This information will truly alter the course of human events. To give us a little update, we're going to send it over to our #1 interrogator, Khaled El Shazli.
Hello, thank you for the kind introduction. I am here with world expert biochemist Nivea Harmon. How are you today?
I'm doing just fantastic and filled with so much pride that a bunch of young minds are finding out the world's burning questions.
It's truly amazing, isn't it? Now, could you please explain what in the world is glycation?
Glycation is when a sugar attaches to a protein spontaneously. Now, we have the ability to attach a sugar to a protein for protection and recognition. However, these are done enzymatically and on purpose. Glycation is done without the use of an enzyme and completely random.
Now, hold up. Why should we care if it's done on purpose or random?
Well, sugars attached to a protein that shouldn't have a sugar on it could block its active site, change its 3D conformation, or block its substrate binding site. In simple, it kills the protein.
That sounds very serious. But again, why should I care? What causes the glycation to occur?
Well, protein runs our bodies. They're the reason that we're living. So if glycation starts to occur and proteins start to die, then if it's not controlled, we'll also start to die. Glycations are caused by sugars, so the more sugar that's in the bloodstream, the more likely proteins will be glycated.
Wow, I just got word that one of the students who helped find this world-changing information is giving a presentation. Thank you so much, Nivea, for your expert knowledge. Sending it back to you, Perrin and Claire.
Just how interesting was that?
Very. Now, while Khaled is running over to the presentation, we have Dr. Jacob and Nurse Trace with us. How are you guys doing today?
I'm doing just fantastic. I'm just so excited that these young minds are finding out the world's burning questions.
I agree. It is so promising to see how much these students care about the world.
So, after learning a little about glycations, how does this affect our local area and population?
Well, people all the time come in with problems, and the first thing that we check is their blood sugar levels because of the simple reason that glycation is messing up proteins. Due to the high amount of sugar found in everything that we eat and drink, people tend to have pretty high blood sugar levels.
Yes, they really do. Sometimes we have patients who come in at 300 milligrams per deciliter and above, and the sugar levels really shouldn't go above 100. When they do go above that, there's a bigger chance and likelihood of glycating proteins.
And how does that seem to affect the people of West Virginia?
Well, diabetic people tend to have much higher levels of blood sugar, and about 16% of all adults in West Virginia have diabetes, indicating a good portion of the West Virginia population will suffer from high amounts of glycated proteins.
Wow, that truly does seem like a big problem. I'm so glad that productive research is being done by students at the Marshall University Chemistry Department.
Now, I just got word that Cameron is with world-renowned glycating expert Bobby. Sending it over to you, Cameron.
But first, a thank you to our sponsor, Dr. Leslie Frost, and for viewers like you. Thank you, Claire. How are you doing today, Joe?
I'm just so happy and amazed by the research done by such talented and bright young minds. I'm actually on my way to watch the capstone presentation on carnosine and glycating proteins.
I'm so happy to hear that. Well, we just got a brief understanding of what glycation is and does from Nivea. But could you please go more into depth about how this occurs and what proteins we should be on the lookout for?
I would love to. Glycation normally occurs with lysine amino acid residues that have lone pairs on them. Now normally lysines don't have lone pairs, but when a lot of arginine residues are near them, the pKa of the lysine side chain is lower and the lone pairs can form more readily. This can cause a shift base between the linear sugar and the protein. Then, as the world expert genius said, the protein can become dysfunctional and die.
How tragic. Well, what proteins should we really be on the lookout for then?
My bet is that this world-changing research focused on one of the most important proteins in our bodies.
No, me digas.
Yes, that is where my bet is. But let's have a look at the real expert, the Marshall University undergraduate biochem lab course.
I agree. Sending it back to you, Claire.
Hemoglobin. I never would have guessed. This story is truly building up.
I know. Every time we think right, we go left. Wild, isn't it?
Word just got in. We have Khaled on the scene of the capstone presentation.
What is biochemistry?
Carnosine is a dipeptide.
World-changing information will do that to people now, won't it?
Yes, it will. Let's go to the MALDI-TOF expert to see what their data means.
Hello, my name is Perrin Shrey. I'm the world expert on MALDI-TOF. Now, what is MALDI-TOF? Well, it's a machine that can detect the molecular weights of proteins and then determine if they've been glycated or not, which is exactly what the undergrad students at Marshall University are trying to figure out in their world-changing research. So MALDI-TOF stands for Matrix-Assisted Laser Desorption Ionization Time of Flight. So that first part, the MALDI, is just saying a laser hits the protein sample, gets it into its ion form in the gases, and then the time of flight, TOF, that's the actual measurement. So it measures how long it takes the protein fragments to go up and hit the detector. The bigger the fragments, the longer it's going to take to hit the detector. So, as we can see from their MALDI-TOF spectrum, their mass spectrums, this is a controlled hemoglobin protein. And so, as you can see from a controlled hemoglobin protein, it has one peak because it should be one molecular weight. Now we go down to their glycated samples that whenever they incubated the hemoglobin with a lot of sugars, we can see one peak, two peaks, three peaks, and even a fourth peak. Now each of these peaks represents a sugar attached to the hemoglobin. And as stated by TEMA and world experts leaders across the world, glycated hemoglobin can cause severe issues. And we can go down even further to go and look at the individual fragments of the glycated hemoglobins to determine exactly what residue, lysine residue, they are attached to. And that was shown in TEMA's capstone presentation. Thank you so much. Sending it back to you.
Thank you for that synopsis. Just got word. The reporters seem to have calmed down a little. Sending it back to you, Khaled and Cameron.
So, she just went over what the mass spec graphs mean. And world glycation expert Nivea was right. They are looking at hemoglobin.
Wow, these young minds are just so bright.
Thank you. Now, one of the issues with glycating hemoglobin is that there are a bunch of lysines surrounding the cleft. Now, if lysines get modified, then the electrostatic interactions become weaker and then the heme might fall out. Not to mention cross leakages. But let's just stay on topic for now, okay? So if the hemin falls out of the cleft, it is nonpolar and it can aggregate. But we may have found a solution for that. Carnosine. This dipeptide might be able to ligate to the hemin that has fallen out of the cleft, and it can keep it in solution. So we ran a couple experiments where we were able to see that the black hemin dots did disappear when carnosine was added to solution. Any questions?
Wow, what a story. Those undergrad Marshall University students are truly one of a kind.
I absolutely agree. Thank you for watching CNFY Chemistry News for You. We will keep you updated about this development as time goes on. And a story from the past has finally come to an end. Claire, you remember that amazingly talented young group of undergraduate students at Marshall University?
How could I possibly forget?
Well, they just won the Nobel Prize for Peace, Biochemistry, Physics, and the Nobel Prize for receiving the most Nobel Prizes.
And they deserve it all. Well, I'm Claire Combs.
And I'm Olivia McCoy.
Signing off with CNFY.
As the world expert, here's the Nobel Peace Prize. As the world expert, here's the Nobel Prize for Biochemistry. As the world expert, here's the Nobel Prize for Physics.
Action!
As the world expert, here's the Nobel Prize for the most Nobel Prizes.
Thank you so much.